Hi, this is Jeff with SabeSoft, and in this video we're going to talk about the Sabe IoT node. In a previous video we talked about a different type of node. This is an AWS IoT button, and we can connect this to Sabe to listen to button pushes or respond to button pushes and do all sorts of neat things like indicate that a Kanban card is empty or that a machine needs maintenance. This particular IoT or Sabe IoT node is configured in a beacon mode. So this is a light stack, and this node knows how to turn these lights on and off depending upon what Sabe tells it to do. So I've taken out the box and we'll go through it really quick, and then we'll talk about how to set this up in Sabe. And in future videos we'll talk about when we would use this, how to indicate that we're running into a time buffer on an IoT or a TOC, theory of constraints buffer, or perhaps our inventory is low in a Kanban location, or maybe a machine's in need of service. So what we have here, this is all industrial computing. This is Lego blocks. Got about $150 worth of parts right here, so it's super cheap. You put it in a box, the boxes are 50 bucks or so. So it's really affordable to pepper your warehouse and your manufacturing floor with a whole bunch of these things. We've got power going in. We've got two power supplies. These are industrialized versions of the things you plug into the wall to charge your iPhone and your laptop. We've got a little computer here, and we'll talk about that a little bit more. And we've got a light stack, and this is just red, yellow, green, and a really annoying alarm that I'm not going to fire in this demonstration. So this computer is a Raspberry Pi. What it is a PC, personal computer that it runs on a single board. This is $35. It was designed for hobbyists and educational uses, but we're starting to see these all over the industrial space because they're so bloody cheap, and they have a ton of features that we can use. This one again is set up not to listen but to yell with lights. We have other configurations, which we'll talk about a little bit later, that can record things instead. So this is connected to the internet through Wi-Fi. It is not connected directly to Sabe. It connects to Amazon's IoT infrastructure, and that's important to remember. Sabe connects to Amazon's IoT infrastructure, and these two communicate through the internet. They happen to be in the same room. Actually, Sabe is running on our cloud, which is not in this room. My laptop and this IoT node are connected to the same Wi-Fi, but these could be on either sides of the world and will be connected through the Amazon IoT structure. So let's go to Sabe. In Sabe, and if those of you who have watched the introduction of the explanation of our support for the Amazon IoT button, remember we have the ability to define IoT devices, and I have something I've called the light stack, which is an IoT node in configuration 1, and this magic number is what we would provide to you that uniquely identifies this particular light stack. Now, this light stack has 4 B outs, or binary outs, basically relay switches. And I've said that they are attached to the green, yellow, red, and alarm wires on the light stack. And that's it. That's all we have to do. If I go to the control panel, I can toggle those binary outs or Boolean outs, and I can turn on the lights. And again, I won't do the alarm, but what's happening is I click that, Sabe goes and talks to Amazon. Amazon talks to this box. This box says, yeah, I hear you and I've done it. That goes back to Amazon and back to Sabe. And you can see that is pretty quick. So this is a beacon mode. Again, this tells us something. We have other versions that are set up as sensor nodes. So, for example, this is $7. This is a digital thermometer, and we can tape this to a electric motor that runs an auger or a heater on an extruder. And in the case of an electric motor, we can monitor the temperature of the motor and notify Sabe when that motor is getting too hot. and we can tell Sabe, look every minute or so. And if the motor's getting too hot, fire off a maintenance request. And that maintenance request may be attached to a different IoT node, which then turns on a yellow alarm. So that's an example of a slow pull. We look every minute, and we do something when the value is outside of a range. We can also, again, attach this to the hopper on your extruder, or the heater on an extruder. So you've got all that plastic going into your extruder, and you heat it up, and then you push it out, and it kind of looks like a Play-Doh thing. In that case, we can throw that data up to the temperature up to big data. So we can record that temperature every second, and then later use that temperature for a failure analysis. Let's say we extrude a piece of pipe, and 20 years later, 20 months later, the pipe fails. Well, the pipe's serialized or lot numbered, and we can go all the way back and find the work order that we used to build the pipe, and we know the start time and the end time of the operation on the work order when we ran the extruder, and we can go to big data, and we can look at second by second the temperature on that extruder motor, or the extruder heater, to figure out if we were extruding at too high or too low a temperature. You can keep that data forever. So what the IoT does, the Internet of Things does, is it allows us to very cheaply monitor things passively, or tell our users and our production employees what's happening on the floor without them having to go to a computer. I don't have to go to a computer and say, hey, I'm out of inventory. I can hit this button, and the person who's walking around and replenishing that inventory doesn't have to go to the computer and say, what do I have to replenish? Or in the case of a Kanban card, look at a card and say, oh, there's a god-awful, ugly pink card sitting over there. I should run over and grab a bin. We can notify them with a beacon. $150. You put them everywhere. Adding more nodes is about $50 a piece. So in the future, we'll talk about some more uses of Sabe IoT's buttons, but we just wanted to introduce them to you in this. Talk to you then.